Hello, I am Govind, presenting alongside my teammates Piyush, Manan, and Bhavishya. We are here to present our application Liquid Defense. Our objective was to construct a lightweight mobile traffic analyzer that captures network flows per application, operating entirely without root access. Traditional AI based malware detection suffers from a critical architectural vulnerability known as discrete time fallacy. Standard sequence model process data packets in fixed, discrete steps, inherently ignoring the physical time periods between those packets. Modern low and slow malware exploits that exact limitation by spacing out its transmission over hours or days. Because conventional AI disregards precise timings, it fails to perceive this hidden beckoning behavior completely. To detect these modern threats, we had to re-evaluate the physics underlying the artificial intelligence. A common challenge in network analysis is that modern payload data is encrypted. However, description is not required for classification. The reality of modern malware is that payload is almost always encrypted. Breaking that encryption violates privacy and is impossible on a phone. But malware has to communicate with command and control servers using mechanical loops. We aren't looking for a malicious mode in the payload. We mathematically identify the artificial mechanical heartbeat of a bottleneck beckoning in the background. Enter Liquid Defense, powered by Continuous Time Neural Network (CFC). We treat time as a continuous variable, explicitly passing the physical time delta between packets directly into the neural network.
This mathematically equips with AI with physics informed memory during periods of high traffic density. The model retrains its contextual memory. During extended silence, the internal memory gracefully decays. The model does not merely process static data, it analyzes the temporal rhythm, effectively neuralizing low and slow malwares. Excluding this advanced AI continuously on the mobile device without depleting the battery requires an entirely new software architecture. Relying on software standard Android networking through the Java virtual machine creates excessive memory overhead and latency. To resolve this, our application established a local Android VPN that routes raw packets directly into C++ native hardware tab. This architecture achieves high-speed interception without requiring root access, extracting protocol headers like HTTP and TCP into milliseconds. Furthermore, by implementing explicit split tunneling, data-intensive applications such as YouTube bypass our VPN interface entirely. This ensures the user experience zero network latency during media streaming, while all background operating system traffic remains strictly monitored and analyzed. A major hurdle in deploying AI to production is train inference queue. Models are often trained on perfectly normalized datasets in a research environment, but completely fail when faced with raw, unscaled network data on a physical device. We recognize that relying on external data pre-processing scripts on Android would inevitably introduce latency, memory overhead, and potential points of failure. To definitely solve this, we elected to embed the mathematical normalization, scaling features, and clamping massive time deltas directly into the PyTorch computation graph prior to export. Now, when our C++ tab feeds raw, unscaled network latency to the ONNX runtime engine, the AI autonomously normalizes the inputs. By focusing the pre-processing directly into the model architecture, we completely eliminated the skew and achieved flawless real-time threat calculation natively on the mobile CPU. This brings us to the live interface. Upon initiating protection, our Liquid Defense Resolution Engine translates raw IP addresses into familiar application names, providing immediate visibility into network behavior. In the event of anomalous traffic, the system triggers a multi-sensory alerting pipeline, combining haptic feedback, visual indicators, and a radar lacon. On immediate actionable prompt empowers the user to block and report the malicious connection, terminating the rogue DNS resolver instantly. Thus,
The result is an advanced endpoint defense tool built for Android. It is lightweight and battery adaptive. The native C++ core ensures background consumption remains under 2%. It is also privacy first. The system operates with zero decryption and transmits zero data to the cloud. All inference is strictly local.